Hi guys, I'm going to review your direct variation edge-elastic quiz today. Starting with number 1, you can pause the video, read the question, and then see how I am going to solve this. Okay, we can find unit rate. We know that K is our unit rate. We can find unit rate K by dividing Y by X. Our unit rate when involving money and hours would be dollars over hours. So dollars is equivalent to our Y variable, hours is equivalent to our X variable. We know we have $30 per 1.5 hours. If we divide that, we get K is equal to 20. So our equation, Y is dollars, so dollars is equal to 20. Our X variable is hours. D is equal to 20H. Okay. Let's look at number 2. It says select all tables that represent a proportional relationship between X and Y. So for each of these, all we had to do is divide Y by X. Okay. Looking at each of the tables, I can see in choice A, it is not proportional because our first point starts with 3 divided by 0. To have a proportional relationship, we need the point 0, 0. So that would not be proportional. Choice B is proportional because all ratios are equivalent to 6. C, we see the first point is 0 over 2. Again, that is not the origin. We would need the point 0, 0. And then in choice D, while we have the origin, looking at all other ratios, they are not equivalent. So our choice would be B. In the next question, we were asked to find the missing component of the table if you're given number of pounds of grapes and total dollars. From this table, I was first able to find my unit rate of 69 cents for 1 pound of grapes. So for each of these, if I set up a proportion, if I know 69 cents for 1, then would that equal $1.38 for 2? There's several ways to go about finding this. I used common factors. So I know that if this is multiplied times 2, then would 69 cents times 2 give me $1.38? And the answer is yes. So A would be a choice. 1 times 3 pounds. If I multiply 69 cents times 253, or I'm sorry, 69 cents times 3, I do not get $2.53. So that would not be an answer. 1 times 6 is 6, so 69 cents times 6 does not give me $3.68. 1 times 8 is 8, so 69 cents times 8 does give me $5.52, so D would be an answer. And then finally, 1 times 11 gives me 11, and 69 cents times 11 is not $8.97, so that is not equivalent either. So my choices should have been A and D. Okay, question 4. We were looking at a graph, and the most important thing was to really pay attention to your labels. Our x-axis was a unit of tablespoons. Our y-axis was a measurement of grams. We are looking for true statements. A 0.630 means that there are 30 grams of protein in 6 tablespoons of peanut butter. That would be true. Choice B says the line passes through the origin, so it is a proportion. It does go through the origin, so that is true. Point A is at 840, which is the origin. We know that is not true. And the unit rate is 30 grams of protein per tablespoon of peanut butter. Well, if we look at our tablespoon where we find 1, our measurement of grams would be somewhere around 5 grams per tablespoon, not 30 grams. So that is not true. And number 5, again, we're looking at a graph and we're looking for the unit price. So price is along our y-axis, number of pages printed is along our x-axis. So in order to find unit price, we want price per page. We can find y divided by x to find our unit price. So I am going to use the point x is 2, y is 1, because I can see that that is a point along the line. I could also use the point that is here, which is x is 6, while y is 3. Either of those points are points where I know the x value and the y value. Notice if I look where x is 1, I would have to estimate what y is, and I don't want to do that. I want to look where I know what the x and y values both are. So in either case, I would divide y by x, so that's 1 divided by 2, or 3 divided by 6. Either of those gives me 1/2, or since we're talking about money, 1/2 would be 50 cents per page, which is choice D. Okay, so interpreting yet another graph in number 6, we're going to look to see which statement is true and which statement is false. The factory uses 4 gallons of water when it is in operation for 4,000 hours. So if I were looking where the factory uses 4 gallons of water, I don't even see anything close to that along this y-axis where I would be looking for gallons. So that would be false. Point W represents the number of gallons of water used when the factory is in operation for 7 hours. So this point does represent where X is 7. So it tells us when in operation for 7 hours, how much water is being used. So that would be true. And then when the factory uses 9,000 gallons of water, when it's in operation for 9 hours, so we're looking to see if at 9 hours, if we follow this up, if we look across, then we will find that that point is at 9,000. So that also would be true. Number 7, we're looking at a proportion, and it says if 4 all-weather tires cost $903.80, how much would 1 tire cost? So if 4 were $903.80, typically we are used to seeing unit price as $903.80. We would have dollars in the numerator, tires in the denominator, so price per tire. And then we want to know, well, how much would 1 tire cost? So we're looking for our dollar amount for 1 tire. And I'll just use T to represent there. And we know that our numerator is in units of dollars. Now, if I look at my choices, I do not see this choice matching anywhere on here. So one thing you need to note about proportions, we've said that yes, when we're finding unit price or unit rate, our dollars will be in the numerator. But our proportion is equal and correct as long as we have our units the same across. So if I flipped my ratios on both sides of the equal sign, I'm going to get the same answer. Okay, notice in the way that I normally would set this up with price in the numerator, I would be multiplying 4 times x. If I flip both the numerator and denominator, I'm still multiplying 4 times x. So that would be 4x. Here I would multiply 903.80 times 1. If I flipped them both, I'm still multiplying 903.80 times 1. So my equation to solve would be 903.8 is equal to 4x. Okay, so I'm going to get the same exact answer for x no matter if I set it up this way or this way. So my answer choice would be A, because I have 4 tires and 1 tire in the numerator, and I have dollars and the value of dollars here that I'm missing in the denominator. So again, the important thing with proportions is that your units are the same horizontally, directly across from each other, okay? In this graph, we're told, number 8, that tax is proportional to price. Okay, so what that means is as price goes up of an item, the amount of tax you're going to pay also goes up. So we have tax on the y-axis, dollars, price of the item on the x-axis. So if we look at which equation represents this relationship, we know tax is on our y-axis. So we can represent in our equation y equals k times x. We can substitute y for tax or t. X is going to be price. So we know that we're looking to fill in t equals kp for the equation y equals kx. We've just given y and x a different variable letter to represent tax and price. So now we can use our graph to find our unit rate because we're trying to find the equation and write the equation of the line. So we're looking for what is our unit rate. Well, unit rate is where our x-axis is equal to 1 because we're looking for unit rate always has our y over x. If we're looking for k, k is our unit rate, and k equals y over x. So I'm going to find my x is equal to 1, and I'm going to look up to see what is y at that point. Well, it doesn't fall exactly in the middle. If I look at this graph, right here would be 0.05, because that's the middle. It's a little bit above that. Well, we know, so it wouldn't be exactly 0.05. It certainly is not 96 cents, and it's not $1.60. So that leaves us with 0.06. We can estimate that that is the closest answer. In number 9, we are interpreting 3 lines on a single graph to determine whether the statement is true or false. The 3 robots have all traveled the same distance after 1 second. Well, here's our 1 second. So if we look straight up, we've got Bob here. Distance for the Hob is a little bit greater, and distance for Cobb is even greater. So that would be false. In 2 seconds, Cobb will travel 6 meters. So I need to look at the line for Cobb. So at 2, yes, he has gone 6 meters. Bob travels the shortest distance after 3 seconds. So if I look at Bob's line, yes, the distance is less when I'm looking at Bob's line. So that would also be a true statement. Okay, we were looking at a rate of jumping jacks and seconds. So we're able to see from the table that the ratios are equivalent and they equal 5 jumping jacks in 4 seconds, or 1 1/4 per second. 5 divided by 4 gives me 1 1/4 jumping jacks per second. So I'm able to eliminate A and B because I see both C and D give me 1 1/4 jumping jacks per second. And then to find out how many per minute, well, if it's 1 1/4 per second, I just multiply that by 60 to get my number per minute, which would be choice D. Okay, in this question, we're giving an amount of water that leaks from a bucket. So it says that she places a bucket under the drip and sees in an hour and a half, the bucket is 1/4 of the way full. So our first part A says, what is the rate at which the water is leaking per hour? So I've gone ahead and set up water leaking per hour. So my unit of time is in the denominator. Well, I know what I'm given is an hour and a half. I'm going to write that as 1.5. You could have also included that as a fraction, 1 1/2. The amount of water is 1/4 of the bucket. So 1/4 divided by 1.5 should give me 1/6 of a bucket per hour. So in part B, we're to write the equation that represents the relationship between buckets filled Y in X hours. So we're just filling in our unit rate. Y equals 1/6 X. What's the longest that Carrie can be away from the house before the bucket will overflow? Well, we know that she was able to fill the bucket 1/4 of the way in 1 1/2 hours. So if we did 4 groups of that, we would have a full bucket. So 1 1/2